In this lecture, we will look at structured programming and some implementation aspects. Let's see what structured programming is and how it originated and how it has been developed into a full-fledged methodology for software design and modular decomposition. So, we will mainly look at the core concepts or core ideas behind structured programming. So, what is structured programming? So, basically we look at modular structural decomposition in a top down fashion. So, when we want to design a system, we have seen during our design lectures that you need to defeat the complexity by decomposing a big system into smaller units or smaller modules which interact or collaborate. So, this decomposition can be done in a top down fashion such that different concerns of the program are implemented as different subsections or modules which are structured in a top down fashion. So, what is the advantage of this top down decomposition? So, the third bullet lists some of the benefits that you get through this top down decomposition. So, first thing is that everybody follows a fixed style. If you follow different rules of structured programming that are laid out, and the programs become more clear, the designs also have clarity due to the top down approach. So, at the top level you understand the top level concern, whereas you can zoom on to a top level concern and then you get into the smaller units which are further refinements of the higher level aspect of the higher level module. So, clarity improves because you can easily conceive concerns at higher level or the aspects at higher level with the higher level modules, and as you go down the lower levels you have the smaller abstractions. For example, you may have a higher level function to perform a transaction, but the transaction can be broken down into different sub transactions, and but at high level you need to understand what are the semantics or what do you send as input and what do you expect as output, whereas the lower level you can further see how the bigger transaction can be implemented or can be decomposed into different sub transactions. So, clarity, productivity, ease of testing, maintenance and ease of redesign and so on. So, these are various benefits that you can get through this following structured style or following the structured programming practices and methods. We are going to look at what exactly is structured programming and from where does it come about. So, what are the basic ingredients of structured programming that gives you from lower level programming to higher level structure to higher level decomposition, which can also be structured. So, why does productivity improve? Because you are able to decompose nicely independent concerns with single entry and single exit criteria. If you are able to decompose different concerns independently and then compose them together to form bigger modules or bigger constructions, such as bigger functions or bigger objects and so on. So, it improves productivity in the sense people are focused on independent components, and once you are done with a component, if it follows various well established principles behind modular design, you can reuse them, you can reuse existing components, you can reuse developed components again and again, and that leads to some of these aspects lead to higher productivity. Ease of testing, it's easy to test independent modules and then take concerns, handle concerns one by one. Easy maintenance, because if something is wrong with a module you can simply replace that if there are no side effects and so on. And similarly, ease of redesign. So, maintenance and design also becomes easier once the methodology is followed. So, at the heart of structured programming is the idea of using only single entry and single exit blocks. So, after having introduced to this some of these advantages of structured programming, we will see why they come about, from where they come about mainly. So, the basic concept that we have to look at is this single entry and single exit blocks. So, we are in this lecture we are going to focus on low level concepts of implementation, such as individual statements and so on. So, not at the high level design aspects which we have seen in some of our earlier lectures on design and architecture. So, during top down decomposition, design a program as a top down hierarchy of modules. So, this hierarchy is developed according to various design rules and guidelines that we have seen earlier. The modules are evaluated as per the quality acceptance criteria to ensure the best modular design of the program. So, you have to evaluate the module as per your quality acceptance, different criteria, metrics and so on. So, we are going to have a special lecture on metrics and some of these criteria of modular design and modular measures of modularity, how good your design is, how good your modularization is. And then the modules are implemented using structured programming principles, the basic structured programming principles, which is going to be a focus of this lecture. So, modular design leads to modular packaging. So, when you do design in modular fashion, it should result into code or your packaging of your software, which is also modular, so that it is easy to handle the software as a distribution package, or the distribution or the release of the software in terms of its modules, its files and its configuration that you need to do for installation and so on. So, the modular design is basically a group of executable instructions with a single point of entry and single point of exit. So, in the group there are many modules and which again follow the structured programming principles, and the packaging is your actual assembly of data, such as files, processes, modules, packages, for example Java packages, your interfaces such as in your middleware you look at IDLs and so on, and even your hardware or machine. So, you need to install or you need to deploy your different software modules onto different machines over the network and so on. So, the packaging aspect is also important, and along with the design, which is your logical construction of your software, the actual physical deployment where you actually place these modules, that also is important, and a structured modular design can lead to good modular packaging, where you can use the packaging abstractions of your given implementation paradigm. Say for example, if you are using C or C++, you can use your hash include files to define your modular interfaces or different modules and keep them independent and have all of the modules implemented in different files. You say for example, for each module which has various functions, which has its own functions, can be implemented in a different C program, and you can separately compile them, so that using separate compilation you can keep concerns differently. You can also create your own independent libraries which can be then linked as and when required. So, modular design should also lead to good modular packaging. So, the programming or the implementation environment must support these constructs, so that you are able to benefit your logical modular decomposition that you do during your analysis and design phase, and then at the same time you also follow the principles of structured programming during implementation, and then you again do good structural decomposition as your deployment entities and so on. So, this method as you can see, can be used in various phases of your software life cycle. So, we are going to look at some very basic ideas which come about from single entry and single exit concept. So, Dijkstra stated this structured programming as basically programming with the help of or using single entry, single exit blocks. And he wrote a paper which was titled as Goto Considered Harmful. So he said that Goto is not good, it results in unstructured programming, because basically if you use a Goto statement in your program, you can write code which is very hard to understand, hard to debug. You can jump from any instruction to any instruction using a simple Goto, and you may not be able to structure your program in terms of well laid out blocks, which can be then connected from smaller levels to higher levels in a top down fashion, so that you can understand the program easily from top down fashion. So Goto has been considered as bad, but you can see that in assembly language you use it quite frequently, use a jump instruction, but at higher levels we have much better abstractions. So when you are at the lowest level you may have to use it, but when you are looking at higher level programming languages, you are handling more large scale problems and you are having more complex problems to deal with. So you have to follow good principles of programming, decomposition, implementation and packaging. So that's where this idea of structured programming is useful, so that you can manage your programs better, you can understand them better, you can test them better, you can implement them better, productivity improves, clarity of the program improves. When you write a program, another person can understand the program easily. So these are some of the various important benefits that you get when you follow these basic principles. So single entry, single exit blocks. So we are going to look at some examples, and we're going to look at, or we're going to explore this more now. So which are these single entry, single exit structures which help you write structured programs from say lower level to higher level modules and so on. So basically you start with a primitive statement. So you have a you have a primitive statement, such as in the imperative style you have the assignment statement. Sequence of statements, S1 semicolon S2 semicolon S3. So you have steps to be executed in any business logic or any algorithm that you write. You have to represent sequence of steps. So your control flows through various steps. So these steps, one after the other, can be executed. So you indicate that by using the sequence construction. So for example, in the imperative style you have this in C you have the semicolon to indicate that after S1 is completed S2 can be done. So then another important construct that we have to look at is the if then else statement, conditional. If condition C is true, then execute S1, else execute S2. So you have this conditional statement where if C evaluates to true, S1 is executed, else S2 is executed. Another important construct that you need is the conditional repetition. So if you have these constructs, you do not need a Goto statement. You can write your programs better. You have to design your loops, or you have to design your conditionals such that the overall program becomes structured. So these are at the core of your structured programming. When they are available and when you do not use Goto, your program will become a structured program. So you have the different forms of repetition. So a simple just a sequence of statement and a conditional will not be enough, because otherwise you will have to use Goto in order to repeat sequence of statements again and again. So conditional repetition is an important construct. So while C is true, you can do S, statement S. So you have this while, the fourth bullet or the third from bottom, you have while. Similarly you also have the repeat statement, you have the for statement, say the C style C++ Java. So you have the for statement, which is a special form of the conditional repetition, which also has the for statement as an initializer. Then you have the starting and the terminating condition as well. So you have different forms of conditional repetition, and you can also include your case statement in it. So besides, you have the top down function calls which give you the modular decomposition, and each function again the implementation of each function follows these basic single entry, single exit structures. So we are going to see some of the pictorial representations of these constructs, of some of these constructs. So they can also be called as flow graph representations. So they basically depict the flow, the control flow, and so you have this first picture that represents a primitive statement. So you can see that there is one entry and one exit for this block, which is a single statement. So before the statement you have an entry and the statement completes is the exit. So this is the simplest form of single entry, single exit, where you have a single statement. Then we have this if then else statement or a conditional statement. If you look at the picture, you have again a single entry and single exit in the for the entire structure. So the important point to see is that this is a single statement, but if you have such statements, now you can take two if then else statement, put them one after the other and call it a block. The whole block can have one entry and one exit. So in the earlier slide, if we add, we can add another statement in the same slide, S1 followed by S2, so that you have the entry, then you have S1, then you have S2, and then the exit. So that gives you sequential form, and then you can combine any of these statements in that form, and then you can build bigger structures which again follow the single entry, single exit rule. So let's look at this if then else statement again. So you have this condition at the top of this block. Once you make an entry into this condition, you have the choice to be made. So if the condition evaluates to true, you execute S1. If the condition evaluates to false, you take the right path and execute S2. So you have the left path or the right path to be taken, and finally you again join at the end, which is your exit from this conditional. So in this way you have the if then else statement which follows the single entry, single exit form. So here we have two forms of conditional repetition, and we can see that these can also be again conceived as single entry, single exit blocks. So on the left we have conditional while do statement, and on the right we have repeat do while or conditional do while statement. So let's look at the picture on the left. So you have a single entry, and after the entry the control flow goes to the condition. So you have this statement called while C do S. So what is the meaning of this? While C is true, you execute S. So when you execute S, it is expected that some or the other time C is going to change, so that this loop terminates. So till the loop terminates, you are going to continue with S. So while C is true, do S. So you can see that you check the condition before you execute the statement. So it may be possible that even before you execute S, the condition may not be true. So this is a precondition for the statement, and you don't execute the statement if the condition is not true, and after the statement is executed, you check whether the condition is changed now, and if it is not, if it is again true, you have to again go back to the statement S. So you can see the flow. When C is executed, after C is executed, the result is either false or true. If C evaluates to true, you execute statement S. After execution of statement S, you have to go back and execute C again. So while C is true, you will be trapped in this loop and you will be repeating S, and when C evaluates to false, S is going to change a variable that is component of this condition C, and C evaluating to false will return the control from this conditional statement. So you have this single exit from this structure. So you have this while do form with single entry and single exit. Now let's look at the do while, where you execute the statement first and then you execute the condition, and again you have a loop. So the form is this: do S while C is true. So as soon as you have an entry, you execute S first. So you, in this case, you always know that S can be executed without any problem, without having to check C for the first time. So you execute S, and then you find whether C has changed or whether C is true or false. If C is true, you go back and execute S again, and if C is false, you terminate this do while loop and exit. So you have both these forms where you can look at these two structured repetitions as single entry, single exit blocks. So we have seen that you have this if then else statement, you have this conditional single primitive statement, and you can also make a sequential composition of statements. So you can conceive each of these statements as say an if then else statement or a repetition statement, and you can put these blocks together and make bigger blocks, and bigger blocks also can be structured with following this single exit single entry property. So we have this repeat S until C, which is slightly different form, where you enter this repetition and execute S until C becomes true. So when if C is false, you go back and execute S once more, and when the condition values are true, you exit from this block. So you use these forms as they are convenient in your programming. For example, when if you want to use while do, if you are processing a file, you want to find out whether the file has no data in it. So you may want to check while you have not reached end of the file, you can do something. So when you know that, you have to first check the condition before you get into the basic statement which you have to loop over your data structure or over your data or file or whichever resource you are using. You use the while do form. So you first check your condition or precondition, and then you go to the statement, and then the condition again becomes your alternating condition. So in this way you can use these different formulations of repeat but conditional repetition. So now we have this flow graph for the for statement, which you use in the C style programming, C, C++, in Java also you have the for statement. So the for statement is as follows: you have Ci, which is your initializer, Ct gives you a terminating condition, Cst is your step, and S is the statement to be repeated. So when we enter into this for structure, we first execute the initialization condition Ci. So first we initialize the variables in this initializer. For example, you have simple for statements such as for I equal to 0, I less than 10, I plus plus, do S, means that you are doing something 10 times and your stepping of I is a simple increment of I. So you are going to increment I from 0 onwards, and we will see how that is done. So this is your structure. In this picture shows the flow of the for statement. So entry into this for block is at Ci. So first Ci is executed, where you initialize your variables as per your code for Ci, as per your Ci, and then you check for this condition Ct. If it evaluates to true, for example, I less than 10, if I less than 10 is true, then you go on to execute S, which is your statement that you want to repeat. So you execute S, and after S is executed, you execute the step Cst. So once you execute the step, go back to check your terminating condition. If that is still true, execute S again. If this is false, then exit. For example, if I less than 10 is false, when I is 9 and you execute S, then step increases I to 10, then I less than 10 is false, and at the time you exit from the for loop. So you have this single exit point and single entry point. So we can see that in this way you can conceive or you can formulate your for statement following the basic idea of structured programming of single entry and single exit. So again we repeat that all these statements can be clubbed together using your sequential statement or using these. So any of these statements which we have seen can be your S square blocks. For example, this S could be an if then else statement or another for statement. Similarly, in your repeat until, this S could be a for statement, or in your condition these statements could be other single entry, single exit forms. So in this way you can build bigger structures which follow the structured programming. In terms of smaller structures which again follow the structured programming principles. So you can build functions or function implementations or function bodies where function bodies do not use a Goto statement and rely on the basic structured program. So these were the ideas explored by Istra, and you can refer to the original paper on structured programming and Goto considered harmful. So we will just put up a few points. So why is Goto harmful? So if you use Goto, these structured programming principles can be broken. So that means it can produce unstructured programs. You can have multiple entry into a block as and when you require. You can jump wherever you want in the program. Multiple exits are also possible. Program become difficult to understand and debug. Very low level programs you do use Goto. For example, at machine language you might use a Goto equivalent jump. You can jump around or using explicit Goto statement at a specific label or at a specific memory address. But Goto is undesirable for high level programming because you want to have good properties. So you can write correct programs, but the problem is that of decomposition, clarity, manageability of your programs, understandability, and also once you have structures you will be able to reason about your programs better, because when you have a specific module that follows a contract, you know that once you test the module and once you follow, if you know that you have followed the contract, you can rely on that function and build bigger functions. So it's use of Goto is not desirable. Structured programming is desirable at when you have, especially when you have to deal with large scale software development. So we'll just take a look at Goto. This is a simple example, but which can tell you how Goto could be used. We do not use it, but we have an example here, and we have a program which eliminates this Goto. So it's a simple program. So you have this marks variable assigned to 20. If marks greater than 80, go to label 1. So jump to label 1. Label 1 prints a grade A, and then jump to last. Last is going to print the label last. At label last you have a statement that simply prints a new line character. Then otherwise, if marks are not greater than 80, the control will pass on to the second if statement, which checks if marks are greater than 60. If it's true, then go to label 2. Label 2 prints a B grade, and again from there you jump to last. If this condition is not true, then you check if marks are greater than 40. If it's greater than 40, you jump to label 3. Label 3 prints a C grade, and again you jump to last, where you can print same. So this is shared. This code is shared, and by all these 3 grade printing functions. And then if this is also not true, then you print F grade and again go to last and print this end of line. So how we can remove this? Go to, so you have this good structured program in terms of if then a statement. So if marks are greater than 80, print A, else if marks are greater than 60, print B, else if marks are greater than 40, print C, else print F, and then finally you come to this. So you are going to exit from here. So you can construct this main as single, or this entire function in terms of smaller structured concepts, smaller structured programming statements. So in this way you can write better programs, and this program you can understand better than this program, because you will have to trace through the whole program in order to understand. Even though this is a simple program, this is perhaps much easier to understand. So in this way you can write better programs So you might still come across software which uses Goto, but now some programming languages do still support Goto. They discourage, but some programming languages have removed Goto altogether. For example, in Java you do not have the Goto statement now, but people have found that programmers need multiple exit forms for the sake of convenience or better clarity, but multiple entry forms are heavily discouraged. So if that is the case, can this question has been addressed by programming language designers, can you have better forms of breaking or exiting from your structure, multiply exiting from a structure, but at the same time your construct should not be so powerful such that you will be able to write programs such as through Goto with multiple entry and full multiple entry, multiple exit formulations, completely unstructured programs. So this has been addressed, and you have some interesting observations here which you will see in this slide. So often this is found to be convenient, multiple exit forms. You must have seen that when you write pseudocode for an algorithm, you write return statements at different places in the code. For example, in the beginning you might check for some condition and return from there if the condition is not satisfied, so that you are terminating the entire function or the algorithm at that step itself, or perhaps with the result as well. So return statement is one multiple exit form which you use often in your functions, and it does improve clarity. We have also an example to show how it can be useful. So it's used where single exit forms may become cumbersome. So exception is one important construct that gives you multiple exits from program or from an object or a function. So you may exit with an exception. So it's much easier to handle exceptions that way, and you may also return from a function. And for loops you have breaks and continue forms. We have two examples in this lecture, and we will look at them. So let's take these examples. So exceptions, this slide talks about exceptions. So you have a function f that returns a value of type t, and it returns some it takes some parameter, say of type any. So this is the first statement. If C, then throw exception E. So C is some condition. It may be obviously in terms of the input parameters. So if you want to throw out, you want to say that the parameters are not in your range, or parameters are invalid, or they are going to result in some error later if you continue with them, you can throw an exception E to the program so that it can handle. So here at this place you are terminating this, you are exiting from this function. Whereas you have this business logic, and you might return a value from the third statement, which is after the business logic is completed, you might return a value here. So you have these two exits, but this makes it much easier or much convenient to write in this way. So you have these two exits, but you don't have a full-fledged Goto, so that you can jump around in the code and write fully unstructured programs. So the above function uses exception at entry level to detect violation of a precondition. The caller needs to handle the exception that is thrown by the call. So if you have programmed in languages that support exceptions, you have the throw catch statement, and with which exceptions can be built. So this is not really a great block or great position to structure programming school, but it's a relaxation of the very strict stringent single entry single exit criteria. So you can have multiple exit, but you don't have multiple entries. With this specific multiple entry form, you can, so it's easier to write exceptions. So different programming languages have different mechanisms of handling exceptions, but this particular form you can see in Java, where you have the throw catch statement. In Smalltalk you have a slightly different way of handling exceptions. We will not go into different mechanisms of exception handling, but this is one of the multiple exit constructs which you can find in modern programming languages. And one small aspect of Goto which people find convenient is addressed by the exception handling mechanism. Now we look at the multiple returns, the return from a function, the return statement, how you have multiple exits and how it is convenient. So, in this particular example on the slide, you have a function that gives you a head node of a list. If the list is null, you return null, else you return the head. So, you may have list head and list tail in the list data structure, and if the list itself is not there, list could be null. So, you have these two return statements. So, the above function uses the return statement twice, thus you have two exit statements to return from the function, and its single exit code form can look as below. So, in this slide you have a temporary variable called h. So, if I is null, you assign h to null, else you assign h to L arrowhead and then return h at the as the last statement. So, you can return finally you can return whatever value you want to return at the end of this function. So, but you can see that this is using one extra variable, and this so which one do you find much easier to understand, either this or this. So, for some it could be also subjective matter, but multiple returns you can see often in algorithm statements or in your pseudo code, so that you can read the code better. And this is one statement which is allowed. This multiple exit form is allowed in programming languages, by programming languages. So, it is not a very major it's not a major violation of it is not considered a major violation of programming. So, this gives you that another aspect of full fledged Goto, which is which may be desirable from readability point of view or from say avoiding temporary variables point of view. Now, we had seen exceptions as one aspect of multiple exit form, or one aspect of Goto restricted to its exit criteria, and this is another return. Now, we have some other modern multiple exit forms which we will look at. We have examples, and then probably we will end this lecture. So, these are unconditional break, that means you can break into an outer loop. So, you have two loops, or you have a loop, you have a single loop, you can simply break from that loop into the outer scope or if you have two loops, you can break an inner loop and break into the outer loop. Unconditional continue continues with next iteration of the current loop. So, if you have a for statement and you might want to check for a specific condition inside the for loop, and if based on the condition you may want to continue directly to the next iteration, or you may want to execute some business logic for that particular iteration. So, you can use unconditional continue form. All these forms are again available in Java, and this is just an example from the Java domain or the Java constructs. Then you have labeled break, where you can break the outer closing loop. You can use labels and then break the outer closing loop using the label break. You have label continue, where you can continue the next iteration of the outer loop. So, we have so these are very interesting multiple exit forms, and you have to use them effectively and as per the requirement. So, so you have to choose exactly which one is required for your program, for your code, which exit form is required or which break or continue form is required for your code, such that the code becomes easy to understand and probably also easy to write. So, this is an example of unlabeled break. So, you have this array of integers, and we want to search for 12. So, you have this for loop for I equal to 0 to I less than length of the array I plus plus. In the array, if you have the element, then you make found it to be true and you break there, so that you do not continue this. So, other option or another alternative design would have been to add this condition elsewhere here, or you have a different form of the repeat. Instead of using for, you can use another conditional repetition. So, but this serves as an example. So, when found it is true, you break and then you come out of this loop, and then you have to again test, because you want to do something here. So, when if found it is true, then you are going to print some value and so on. So, this is your unlabeled break, where you break from the loop. So, if you had an outer loop, you would also break into the outer loop when you break from this inner loop. So, this breaks from for into the outer scope, which in this case is your main statement. This is an example of labeled continue. Now, in this particular code, you are finding a substring in another bigger string. So, S is your bigger than the sub, which is your. So, in this particular example, you have this bigger string called search substring with or within this, and your substring is within. So, you have this outer loop which iterates over the bigger string, and you have this inner loop which iterates over the smaller string, and if you find if the characters mismatch, then you continue with the outer loop and move one position to right. So, this continue outer continues with this step of the outer. So, this is a convenient form which you can use when you have this nested loops, and you can continue. This is a labeled continue. So, you have a label outer, but you can see that you are not using it as a goto statement, but you are using it as a way to break or way to exit from the inner loop, so that you can continue with the outer. So, with these constructs, you are actually not using the full-fledged goto, but you are using it in a restricted way, where most programmers find goto convenient. So, instead of giving a full-fledged goto, this you can say that this is a diluted form of using multiple exits, or basically breaking your loops into inner loops into outer loops, or breaking loops completely, or just breaking the current iteration and so on. So, we have examples only for these two forms, but you can find other examples in programming language literature, and similar examples are there. So, wherever convenient, these could be used, but as you can see, the core principle is that of having single entry single exit formulations, and they can be nested together to give you bigger structures, which are again as per the structured programming principle, and these give you the benefits of all the benefits of structured programming, so that it's much easier to understand, write, debug, maintain, test your code, and ultimately good principles followed at code level or at micro level give you benefits at macro level. So, the principles of software engineering are actually few, and if you apply them at all levels, the quality of the product and the process benefits improve considerably.